So good morning to one and all. So myself Sreekanth. So I belongs to Department of Computer Science, Engineering and Data Science. So currently I am teaching one of the subject for third year first semester, that is cloud and big data. So today I want to discuss one of the concept from cloud and big data, that is related to cloud resource management and performance optimization. So previous videos have discussed about cloud and big data, different concepts like introduction to cloud computing, introduction to big data. After that, we discussed one of the video about cloud storage management, data management, cloud databases, NoSQL databases. All these concepts we have discussed. So today I want to discuss about completely about cloud resource provisioning, cloud resource management, and cloud resource optimization. So, and the performance optimization we'll discuss. And the main agenda of today's session is resource provisioning and management, and elasticity and scalability, cloud resource monitoring and optimization, and cost optimization and resource allocation strategies. We'll discuss one by one concept. And the first concept is resource provisioning and management. So, before going to this particular concept, whatever it may be application we are developing in cloud, any service cloud like maybe AWS or GCP or Azure, any particular service provider if you are using for your application development purpose. So, we need to manage the resources properly, means effective utilization of resources are very, very important. Finally, we need to ensure we need to maximize the performance of your entire application. Finally, and at the same time, cost effective. We need to reduce the cost also. So, if you are not utilizing the cloud resources properly, so unnecessarily they will charge, and at the same time that may impact the overall performance also. So, for that only we are discussing all these concepts like resource provisioning, resource management, all these things. So, first concept is resource provisioning. Resource provisioning is nothing but resource provisioning and management is nothing but in a cloud. So, allocating and managing computational resources like for example, we are developing one particular application, e-commerce applications in cloud side. So, what we required for that particular application development, we required some of the computing resources like virtual machines we required, and CPU, how much CPU is required to process that, if required a GPU, so what are the GPUs you require, TPUs, computational power which is required to develop your application. At the same time, memory, how much memory is required for your application, then storage or else networks related resources, whatever you required, we need to allocate those resources to your cloud applications, whatever the applications we are developing in our cloud. Finally, what will ensure if you are allocating the resources to your applications, nothing but finally we need to ensure optimizing the resource utilization and minimizing the costs. We need to optimize, means effectively we need to utilize the resource, cloud resources. Finally, we need to minimize the cost. So, first thing is resource provisioning. Okay, what exactly this resource provisioning? Resource provisioning is nothing but allocating the cloud resources to applications. And okay, here how you are allocating, what are different ways to allocate the resources to your cloud application. So, there are totally three types of resource provisionings are there. One is static provisioning, the second one is dynamic provisioning, and the third one is dynamic. Second one is dynamic provisioning, and the third one is elastic. The third one is elastic provisioning. So, what exactly each and every type of resource provisioning? So, first one is static provisioning. In static provisioning, resources are allocated manually based on your demand. Based on your demand, means here we need to observe one point about the static resources. So, in static resource provisioning, resources are allocated manually, not automatic. So, we need to remember that point. And here in this particular static provisioning, okay, before using all the resources, before allocating the resources, we need to know in advance how many resources we require to process or to develop our application. So, means we need to predict the resource needs, how many resources we require. So, in static provisioning. So, one of the example for static provisioning, that is suppose for example we are developing an e-commerce website, e-commerce application. So, we are allocating a fixed number of resources, means in advance if we know we are predicting these many VMs. Let us assume, suppose for example I required 10 VMs. Okay, and I required a boot disk size is something 500 GB is required. Okay, something like, so if required network resources also, like ingress postgres tools, so you can incorporate. So whatever you require, just you allocate. Okay, means you need to fix. Why? Because in advance you know how many resources, what are the resources you require for your application, e-commerce application, already we know. So then what will happen? Okay, you can handle even in off peak hours or a peak hours. Peak hours nothing but suppose in during sales like a big billion days. So for example, if we are taking, that is peak hours. So during peak hours also we can handle without any interruption. So that is the advantage of okay, this static. But so static provisioning is not good for a real time purpose. Means when you are working in a production environment. So if you are deploying this particular application in production, static provisioning is not good. Then we are moving to the next second type of provisioning, that is called as a dynamic provisioning. Dynamic provisioning is nothing but something that it is different from static. Static is nothing but manually we are allocating and we are deallocating the resources. Dynamic provisioning, resources will be allocated dynamically, means automatically resources will be allocated based on the demand, based on your real-time demand, like maybe peak hours, midnight, we have a huge demand for your application. At that time, the resources will be allocated automatically. Manually, we are delegating, means whenever, okay, suppose off-peak hours are there, off-peak hours nothing but there is no demand for your application. During that time, automatically resources will be deallocated. So, in dynamic provisioning, okay, here automatic resource allocation will be there. Okay, and deallocation will be done manually. Okay, let us consider, suppose for example you have one real-time application like video streaming applications. Maybe you are using Netflix or any other, okay, streaming OTT platforms are there nowadays. So what we are doing here, during weekends we have a huge requirement. So during that period, like Saturdays, suppose for example if you are assuming Sundays, we required suppose for example 100 VMs you required. So as per the demand, real time, like on the spot, whatever the number of VMs is required, those many VMs will be allocated as per the requirement. Then deallocation will be done manually, means once off peak, means during the weekdays. So automatically, okay, we need to delete all these resources which are allocated to our streaming application. So that is something called dynamic. Then coming to the third one, okay, this is the best okay, suited for your real-time production environment. So elastic provisioning, nothing but, okay, we don't know at what time we have a requirement. Suddenly we required, suppose for example at 11 o'clock I don't have a requirement, but suddenly 11:10 I required okay, 100 VMs. Suddenly instantly we required okay, more number of VMs. Maybe after 5 minutes, suppose 11:15, I don't want 100 VMs, only I required 10 VMs. In that case, okay, automatic provisioning will be done and deprovisioning. Allocation of resources automatically will be performed, okay, instantly, and at the same time, deallocation of resources also will be done instantly. So that is a elastic provisioning. So resources are provisioned in flexible manner, scaling up, scaling down, whenever you required. Off peak hours, so scale down. In peak hours, we required a scale up. Automatically, that will be done. But at what type of use cases we are using this elastic provisioning is nothing but, so whenever you have workloads, you cannot predict, means unpredictable workloads, we are using this type of provisioning, elastic provisioning. And variable workloads, like moderately varying workloads, you can use dynamic provisioning. Okay, if you are not able to predict the workloads, at what point of time you have a heavy traffic to your application, if we don't know, then in that case we are choosing this elastic provisioning. So let us see the difference between dynamic provisioning. Dynamic provisioning and elastic provisioning are almost same. So dynamic provisioning, we are adding something like instantaneous adjustment. That is something we are adding, then it becomes elastic provisioning. So the basic difference between dynamic and elastic provisioning with respect to different aspects like flexibility wise, response time wise, complexity wise, scalability, we'll discuss. Flexibility, moderately flexible, means dynamic provisioning is moderately flexible based on predefined rules. Why? Because here we are setting some rules, like if CPU utilization is greater than or equals to 85%, then in that case we need to scale up, or we need to add one more VM. Something like, whenever this particular rule, a predefined rule we said, if this particular rule is satisfied, then only resources will be allocated. Means resources will be allocated means scale up will be performed. Okay, but in elastic provisioning, okay, highly flexible means real time adjustment, means instantaneously, means you don't have a time. Okay, maybe 11:5 you have a normal workload, 11:6 or 11:7 you have a huge demand. Okay, 100 VMs, automatically we need to scale up 100 VMs, 10 VMs to 100 VMs we need to scale up. That is something called elastic provisioning. Means there is no predefined rules. Means previously we said some predefined rules in dynamic provisioning, but here there is no predefined rules. Automatically, okay, real workload resources will be allocated to your application. And response time for dynamic provisioning, this is a periodic adjustment. We are saying that okay, at what time you will get high. Okay, we are setting some times. Okay, and there is a slight delay. There is a slight delay to get the response, but in elastic provisioning, instantaneous adjustments, real time response, immediately you will get the response. Whenever you have a requirement, immediately resources will be allocated, but in dynamic provisioning that is not happened. Complexity wise, real time dynamic provisioning is relatively simple and rule based, and compared to your dynamic provisioning, elastic provisioning is more complex and may use predictive algorithms. At what time you have a huge demand for your application, so that we need to predict by using some predictive algorithms. Scalability wise, scales based on the thresholds. Once these thresholds are met, so according to that resources will be allocated. So here, so scalability in elastic provisioning seamlessly scales in and out based on immediate needs. Immediate, there is no time. Okay, so immediately you required 100 VMs, 100 VMs needs to be allocated. Immediately you required only 10 VMs, those 10 VMs will be allocated. So like this, allocation and deallocation will be done automatically as per the requirement. Real time demand, based on the real time, so the resources will be allocated and deallocated in elastic provisioning. So cost wise efficient, but may have a slight lag. Okay, and similarly elastic highly efficient, minimizes the resource wastage. Okay, maybe in dynamic provisioning sometimes resources may be wasted. Okay, but here effective utilization of resources will be done in elastic provisioning, so that the cost will be reduced. But that's why here in real time scenarios, in production environments, we are using this elastic provisioning. And use cases suitable for predictable and moderately variable workloads. Predictable, certain extent you can predict, okay, these are the resources we require, certain extent you can predict. But in elastic provisioning, okay, if you have a use cases like unpredictable workloads, you cannot predict at what time. Okay, for your application there is a huge demand, so we don't know at what time. Even a normal day, suppose there is a demand for your application, we don't know at that time. Okay, so at what time, at what second, at what minute, at what hour, we don't know. Okay, the requirement of resources. So in that case, we use elastic provisioning. So that is about resource provisioning. There are three types: static, dynamic, elastic provisioning. As per the requirement we are using, mostly we are using dynamic provisioning and elastic provisioning. Especially for unpredictable workloads, we are using elastic provisioning we are using. And the next concept is that is resource management. Resource management is nothing but monitoring and controlling and optimizing the cloud resources to ensure application runs smoothly and cost effectively. Finally, when we are developing any kind of application in our cloud, so resource management is very, very important. We need to monitor. Means for example, I am using a healthcare related application I am developing. Okay, how many resources you required? How many resources are utilized properly? How many resources are ideal? Okay, resources are allocated to our application, but sometimes resources may be ideal, sometimes resources are ideal. That is not correct. Once the resources are allocated means they will charge. So, but effective utilization of those resources are very, very important. For that effective utilization, we need to monitor by using some monitoring tools. Okay, there are certain process and technologies we have to monitor effective utilization of your resources so that you can reduce the cost. For that, first thing is monitoring. So monitoring is nothing but continuously we need to track the performance and utilization of resources, cloud resources like a CPU utilization, how much, memory usage, how much, okay, then networks, how they are using, storage, how much storage space is utilized so far, and all these things, whatever the services you are using in a cloud, every service, how it is using your cloud resources. Okay, so if some resources may use, okay, maybe more number of resources, if some services may use low resources, maybe some resources may not be used properly, so you can track by using that monitoring. Okay, so then the next one is load balancing. Okay, load balancing, how you are optimizing this. Load balancing is nothing but when you are implementing a e-commerce related application, so for example, there is a huge demand during the weekends, or else maybe big billion days, something, some offers they are giving generally during a festival season. So during that particular period, we have a high demand for your application. Means a more number of millions of users that are using your application. So at that time, suppose for example, you have one server, suppose for example, you are using, all the requests are goes to only that particular server, there is a burden on that particular server. Okay, obviously that server becomes bottleneck. Okay, means maybe at one point of time your server may be crashed or maybe down something. Okay, to avoid that, what we are using a different servers, like three different servers we are using, server 1, 2, 3, 4, something like that we are using, and we are forwarding the respective request to the respective servers. Okay, here whatever the requests we are getting, we are distributing the workload to all the servers equally with the help of load balancers. For every service provider provides different types of load balancers. Global load balancers, local load balancers are there. As per your requirement, you need to use the respective load balancers so that the workload will be distributed between all the servers. No server will be overheaded. Okay, finally, we can run our application smoothly without interruption, without a downtime. And the next one is scaling. Nothing but adjusting the number of resources allocated to our application based on demand. Like based on for example, you have a peak hours, during that time only we required. Okay, so in that case we are using something called feature called as a scaling. Okay, automatically you can scale out and scale down whenever you have a requirement, you can scale out, and whenever you don't have a requirement, scaling. Okay, something like we are using adding the resources and removing the resources, that is something called as a scale in, scale out. And the next one is optimization. Optimization is nothing but you need to utilize the resources in an efficient manner. So finally, we need to maximize the performance and minimize the cost. That is the intention here. So how we are optimizing the resources? Nothing but here we need to use something called as a right sizing. Right sizing recommendations, nothing but here we are using for our application, there are different types of VMs we are using, like 2 vCPUs, something we are using 2 vCPUs or 4 vCPUs, something we are using. No? So as per your requirement, suppose if required only 2 VPUs, you can use 2 vCPUs only. If required 4 vCPUs, okay, you can use 4 vCPUs. If required 16 vCPUs, you need to use 16 vCPUs. Unnecessarily, if you are using 16 vCPUs instead of 4 vCPUs, unnecessarily you are utilizing, you are using 12 vCPUs. Unnecessarily, they are charging for those 12 okay, virtual CPUs. So that is not correct. Whatever you require, exactly you need to use the required size. 2, 4, 6, something like that you can use as per your requirement. So some of the examples for resource provisioning and management in cloud services with respect to different cloud service providers like Google Cloud Platform, Amazon Web Services, Azure. So let us consider AWS side, what are resource provisioning tools and management tools are available. Auto scaling, automatically adjust the number of VMs, nothing but here we are calling as a EC2, Elastic Cloud Computing. instance in response to the changes in demand. Whenever you have a high peak time, so during that time you required some more number of EC2 instances. So similarly, we are using here elastic load balancers. Already I mentioned every service provider provides some types of different types of load balancers. So as per the requirement, we are using the respective load balancers to your application. AWS Cloud Formation. So it will automate the provisioning of infrastructure through templates. Okay, we are not doing manually. Okay, here we have some template. So as per the template, automatically it will provision the resources wherever you required with the help of AWS Cloud Formation. Similarly, from Microsoft Azure side, Azure virtual machine skill sets, like so same type of virtual machines are grouped together, similar type of configuration grouped together. Whenever you have a requirement, those machines will be added, and whenever you won't require, it will be deleted from that group. Okay, similarly, Azure Monitor to monitor completely to track the resources utilization with respect to your applications. So we are using Azure Monitor. Similarly, Azure Resource Manager, it will enable the management of resources through templates, like your AWS Cloud Formation, how it is working. Similarly, your AWS Resource Manager is also working. Whenever you require resources, that will be allocated resources through template. All the infrastructure, whatever you require for your application, so all those things will be allocated through template only. Similarly, from Google Cloud side also, they are providing the GKE Google Kubernetes Engine, that is a container managed service from the Google side. So automatically scaling and scale up and load balancing will be done within this GKE Google Kubernetes Engine. Similarly, Compute Engine Autoscaler. So here we are creating something like in managed instance groups we are using. So we are creating a group of virtual machine with a similar kind of configuration. So whenever you require, so these machines will be allocated to those applications. Whenever you won't require, simply machines will be deleted. So with the help of autoscaler, based on some thresholds like CPU utilization, storage space is consumed for applications, so on. So based on that, so you are setting some predefined rules. Based on those predefined rules, this will be done. Okay. Similarly, Cloud Deployment Manager, just like your Resource Manager in Azure as well as Cloud Formation in your AWS, it automatically creates the infrastructure for your application. Okay, that is using some templates. So that is a deployment manager. Okay, so then next one more concept that is very important concept in our resource provisioning monitoring is elasticity and scalability. What exactly this elasticity? Elasticity and scalability, these are the two important concepts in our cloud computing that will enable applications and services which you are using for your applications for handling the varying workloads, and finally we are ensuring that optimal performance and cost efficiency. That is a very important point. Optimal performance and cost efficiency purpose we are using these two concepts in our cloud application, elasticity and scalability. What exactly this elasticity? Elasticity refers to the ability of a cloud environment to automatically provision and deprovision the resources in response to the changing demand. Like here, elasticity is nothing but just like elastic provisioning. What will happen in elastic provision? Based on the real-time demand, automatically it will be allocated resources as well as resources will be deallocated whenever you won't require. Similarly, elasticity is nothing but, so automatically it will check whether you require the resources, then automatically resource will be added. Something you won't require, then automatically the resources will be deleted. So that is something called as a elasticity. Okay. Finally, what it will ensure if you are enabling this elasticity concept, nothing but as a application has exactly the resource it needs at any given time. It ensures whatever the resources you require, those many resources only you can use. You cannot use more than that or less than that. Okay, means suppose I required 100 VMs at one particular point of time, so only these VMs will be allocated to your application. Means exactly we can allocate the resources whenever we required. So the key characteristics of elasticity is automatic adjustment. So name itself represent. So resources are automatically added or removed based on the real-time demand. And the next one is cost efficiency, means if you are adjusting the resources dynamically, okay, so you can minimize the costs, only you need to pay whatever the resources you are utilizing for your application development. Like just now I mentioned, suppose 100 VMs are required at one particular point of time, only you need to pay the amount for only 100 VMs. Okay, suppose in off peak hours, suppose I required only suppose 10 VM, only you need to pay for only those 10 VMs, not for 100 VM. So like this, you can reduce the cost also. Okay, so immediate response, elasticity. Okay, so you will get a response immediately, instantly, whatever the workloads are changing. Okay, we don't know at what time there is a huge demand. Okay, at one point of time we don't have, we don't know exact requirement of the resources. Why? Because suppose okay, at 11:10 I have a requirement of like 100 VMs we required. Maybe after 10 minutes, 11:20, I want only 10 VMs. Then after 11:25, suppose I required 50 VMs. Means changing, the requirement is changing like 5 seconds, maybe 10 minutes or maybe 15 minutes. Every 10 minutes, the requirement is changing with respect to your application. So whenever you have like that, then in that case we are using this elasticity. So this you can apply for any domain like e-commerce application development or maybe healthcare, insurance related. Okay, suppose best example healthcare domain, maybe e-commerce related. Suppose you have a flash sales, means big billion day sales we have. So suddenly there is a huge traffic to your application. So elasticity will enable automatically, it will provision adding the VMs, or maybe off peak hours automatically it will deprovision the resources that will be handled with the help of this elasticities. And the next one is scalability. Scalability is nothing but capability of a system to handle increasing workloads by adding resources either vertically or horizontally. This is something called as a scale up and scale down. There are two types of scalabilities are there here. Vertical scalability is there and horizontal scalability is there. Vertical scalability is nothing but increasing the capacity of existing resources. Like you have a one VM is there. Previously, you are taking a VM with a configuration like a 2 vCPUs. You are taking and 10 GB boot disk you are taking something. So if this is not enough for your application development, okay, if there is a possibility to increase this configuration, you can increase to 4 vCPUs and 500 GB hard disk you can take, boot disk size, 500 GB boot disk size you can take. So like this, you can increase, okay, the resources within the same machine. So this is something called as a vertical scalability. If you are adding the resources to the existing machine, that is something called as a vertical scalability. Suppose, for example, okay, this is not enough, means a certain extent only we can increase or increase the machine capacity. Then after that, you cannot add the resources. In that case, we are going with scale out. That is something called as a horizontal scalability. In horizontal scalability, resources are added horizontally, like a more number of machines will be added, something like this. Okay, more machines, V1, V2, V3, V4, something like this we are adding. Then next, this is one of the example for social media platform for scalability purpose. Okay, social media platform anticipate the study increase in users over the next year. Okay, means next year, suppose we are assuming that there is an increase in traffic with respect to your application. So then in that case, what we are using here, horizontal scalability we are using, means we are adding a more number of servers to the existing infrastructure. Okay, so this is something called as a scalability. Okay, elasticity is nothing but based on real-time demand instantly. Okay, the resources will be added, that is something different. Scalability is nothing but, so there is a demand, okay, but on demand only we are using this scalability also, but manually we need to set like a certain predefined rules we need to set. Whenever those predefined rules are matched, then only this scale up or scale down will be performed. The basic difference between elasticity and scalability with respect to different aspects. Automatic adjustment of resources in real time, that is something called as a elasticity, and scalability is nothing but ability to increase the resources capacity as needed. Whenever you require, then only you are adding the resources. But here automatic adjustment will be done in elasticity. Response immediate and dynamic, immediately you will get the response, okay, but it will take some delay. Here in scalability, planned and often gradual. Focus, cost efficiency and responsiveness. Here growth and long-term capacity purpose we are using. So here elasticity, for what purpose we are using? Our major focus is to reduce the cost, okay, to reduce the cost and immediate response whenever we require, okay, then we are using elasticity. But scalability, for a long-term purpose we are using, okay, means during next year, okay, during same time we require suppose 1000 VMs. So like that we are using scalability. We know, okay, at what time we required okay, these many resources. According to that we are using scalability. Types, here there is no types of elasticity, but scalability, vertical scalability, horizontal scalability, there are two types. And use cases purpose, here we are using handling variable and unpredictable workloads like your elastic provisioning type. So here scalability is preparing for predictable and growth in demand, okay. So that is about elasticity and scalability. So how we are using elasticity and scalability in our service providers? Examples like key GCP services that provides elasticity like GKE, Compute Engine, Autoscaler, Cloud Functions, App Engine. These are all provides elasticity. Automatically resources will be allocated whenever you required when you are using these services like Cloud Functions, okay, App Engine. These are all okay, automatically resources will be allocated and deallocated. That is something called as a automatically based on the demand. Suppose immediately we required okay resources, so that will be done with the help of those services. Similarly, okay, here some of the services okay, with respect to key components, and elastic scalability purpose, again we are using some managed instance groups, auto scaling policy. Scaling means here Google Cloud or Compute Engine Autoscaler dynamically adjust the number of virtual machines like instance groups we are creating. So those instance groups are manages automatically. Whenever you have a huge requirement, so automatically resources will be allocated. Then whenever you have a off-peak hours, there is no demand, then automatically resources will be deallocated. Here the major components in this Google Cloud Compute Engine Autoscaler is MIGs, Managed Instance Groups, Autoscaling Policy. We need to set policy on what basis we need to adjust the resources, like if CPU utilization is greater than 80-70% something, or else the storage capacity is crossing more than 500 GB, okay, something. So based on that we need to adjust the resources. And scaling modes like target based, okay, and schedule based, or else at what time we need to add the resources. We need to set the scaling modes also here in Google Compute Engine Autoscaler. And this is one of the example scenario for your automatic adjustment. Imagine if you are running one web application that experience varying levels of traffic throughout the day. So during peak hours 9 to 5 p.m. the traffic is high, or off peak hours traffic is low, okay. Finally we need to ensure our application can handle the load efficiently without manual intervention. So without manual intervention we need to handle this situation. So how we are handling this? For that purpose we are using a GCP related one service, Google Compute Engine Autoscaler. For that I am creating a managed instance group test. Then after that I am setting auto scaling policy. If the CPU utilization is greater than 60%, okay, then we are okay, enabling this autoscaler. And finally we are monitoring the traffic to your application. So how your application is responding to the user request. So when you are using this autoscaler, so easily we can handle whatever the request forwarded to your application. So without downtime you can work with your application smoothly without any interruption also. Then the next one is cloud resource monitoring and optimization. Okay, the cloud resource monitoring and optimization involves tracking the usage and performance of cloud resources and making adjustments to improve the efficiency. Means for what purpose we need to monitor this? So if you are running one specific application in cloud, so you are using a different services, like suppose you are using a GCP cloud and you are using a BigQuery, VM, cloud functions, something pops up you are using. All these services, how they are taking the resources, we need to monitor, we need to track time to time. So if some services may take a huge number of resources, if some are not taking or some are taking a medium, something like we need to monitor. So based on that, we need to adjust the resources, okay, so that we can reduce the cost. Finally, we can improve the performance. Okay, suppose if you are not monitoring properly, if one specific service taking a more number of resources, and at the same time during peak hours, if they are not able to, okay, perform properly, then that will impact on the overall performance. That will impact the overall performance of your application. For that, okay, we are using a different techniques. Okay, cloud resource monitoring. Okay, what we need to do here? So we need to collect the metrics. Okay, metric collection, gathering data, various aspects of cloud resources like CPU usage, how much CPU usage, memory usage, network traffic, IOs, disk IO, how many input output requests we are forwarding to our disk. Okay, application specific metrics. First, we need to collect all these metrics whenever you want to monitor. So alerts and notifications, we need to create alerts. Okay, setting up alerts to notify the administrator when certain thresholds are reached. So once you collected all the metrics, like let us assume if CPU utilization is greater than 80%, we set, okay, then based on this, okay, we need to set alerts, like if it is meeting this particular condition, if any CPU or any virtual machine, okay, meets this particular condition, CPU utilization is greater than 80%, then you need to add. So immediately for those administrators, you will get alerts, means either through different communication channels, maybe Slack bots or webhooks or email or mobile. You can mention the notification channels also, so you will get the notification, so that you can adjust the resources as per the requirement. And you can create the dashboards for those metrics. What are the metrics we collected? For those metrics, you can create the dashboards, like how it is creating, like CPU utilization, how it is utilized. So like this, you can mention certain extent how it is. You can visualize the metrics in a real time to provide an overview of resource utilization and overall performance. And cloud resource optimization. So how we are optimizing the resources, cloud resources. So like right sizing is one parameter we are using, means adjusting resource allocation to match the actual needs. Like if required 10 vCPUs, then you need to use 10 vCPUs. You need to use as per. If required only 5 vCPUs, you can use 5 vCPUs. Whatever the exact size you required, you can use, so that you can perform this resource optimization. Auto scaling, automatically adjusting the resources based on the demand to ensure the applications have necessary capacity while minimizing the cost. And the cost management we need to look, and performance tuning. Okay, sometimes we need to change the certain parameters with respect to database servers when you are running the queries. So you need to follow certain things like query optimization kind of thing we need to perform. So if you are using a materialized views, then what is you can improve the certain extent performance. So like that, we need to tune whenever you required okay, certain parameters we need to change, so that we can improve the overall application performance. At the same time, we can utilize the resources very effectively. So one of the application here, like e-commerce related applications, how we are performing cloud resource optimization. So cloud monitoring, with the help of cloud monitoring, we are tracking all the resources usage, how CPU utilized, how the memory or maybe network services or other application related metrics, how they are performing, all the dashboards we are creating with for that. And after that, we are creating alerts and notification. Okay, so based on that, we'll get as a administrator, you will get those alert. So once those policies are set, okay, once those policies are met, whatever the rules you specified, conditions you specified, once they met, you will get respect to notifications through mails or through mobiles or through webhooks you will get. And right sizing and auto scaling, okay, we'll use, okay, whenever we are using, okay, cloud recommenders, they are analyzing the usage patterns of your virtual machine instances. According to that, it will resize. Like if more number of resources are utilized, according to that, it will suggest you require a more number of virtual machines for your requirement. And finally, we'll analyze the billing reports and cost management. Okay, and finally, we can tune whenever you require the, with respect to application related metrics, like you can tune, like when you are using databases, when you are using database servers, so how you can optimize the queries, so like that we can use with respect to performance tuning. So that is about okay, resource optimization, guys. So overall we discussed about cloud resource provisioning, resource management, scalability, elasticity, resource optimization. Okay, all these things we discussed. Finally, you can uh, maximize the performance, and we can minimize the cost of the resources for your application. So that is the main motive of this particular video. Thank you, one and all.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.